So this is 3-1, and it's lines and angles. So we're going to talk about two different types of lines, and then planes as well, and then the different angles that come from those different things. So first of all, can you tell me what parallel lines are? Lines that won't intersect, right? And they're coplanar. They lie on the same plane. So lines that lie on the same plane that don't intersect. So we're going to say coplanar lines that don't intersect. And the reason coplanar matters is the next type of lines that we're going to talk about don't intersect either. So you just have to keep in mind these are the ones that lie on the same plane. So like on my piece of paper or on my clipboard here, a line here and a line here, that would be on the same plane. My clipboard would be the plane, right? So if I gave you this picture, I'm going to draw it down here because we're going to use it for a couple different things. So if I gave you a box, and this is A, B, C, D, E, F, G, and H. Okay. Could you tell me a pair of parallel lines right now? GH. Is that what you said? GH would be one line. What line is parallel to GH? So this line back here is parallel to what? EF would be one, right? GH is parallel to EF. GH would also be parallel to DC, and it would also be parallel to AB. So all four of those lines are considered parallel, just one line at a time. So if I drew a diagonal through, then AB is parallel to HG, because you could put a plane through them. Okay, so those are parallel lines. I could also say that AE is parallel to BF, for instance. Okay, so lines that will never touch, but you can draw a plane through them. Okay, that's parallel lines. Then there's also skew lines. And these are the ones where the whole coplanar thing matters, because for skew lines, they're non-coplanar, so they're not going to lie on the same line. Non-coplanar. That don't intersect. Okay, so for these ones, it would be something like, let's see, DH back here. Okay, so that's the back edge of our box. We're looking for a line that's not going to intersect that, but also is not parallel to it. Can't be in the same plane. Do you see a line that would work for? If I have DH, you can kind of think of it like a Kleenex box here. Right? Let's say this is my box that we're talking about. If I take this line here, okay, this would be parallel, right? So those two are parallel. But if I took this line and then I did this line, those two are never going to touch, right? This one's going to keep going, this one's going to keep going, but they're never going to touch each other. But I also can't put a plane through them. So they are non-coplanar, and they don't intersect. So like DH and EF, right? Those will never meet up because the DH is going to pass behind the EF. That's what skew lines are. Do you see that? Yes, no, maybe? They'll never meet, but they also aren't in the same plane. So they're not parallel. Tell me, okay, so DC. What is skew to DC? Which ones are never going to touch it, but also are not parallel to it? There's 4 lines here. F what? But give me a line, not a point. F what? FE would be parallel to it, right? It's sitting on the same slope as that. BF would be 1, right? Those are skew. Or FG would be 1. AE would be 1. And HE would be 1. So those 4 lines are skew to DC. They'll never touch, but they're not parallel. Okay? All right, last one is parallel planes. And this one, we're just talking about an entire surface now, right? So the rectangle or the square that makes up our cube. We're looking for 2 planes that are never going to touch, okay? So planes that don't intersect. So if we're going to name planes here, how many letters do you need to name a plane? Do you remember? Chapter 1? 3, right? 3 or more. So you can use 4 if that helps you to see the whole plane. That's fine. So I could say like plane, how would I name this plane? ADCB or ADB or ABCD. So I'd say plane, we'll just call it ABCD. You can use any 3 of those 4 letters. Is parallel to which plane? Can't really see my letters anymore, can you? Which plane is parallel to that top plane? EFGH, right? So the top is parallel to the bottom, and you just need 3 of those 4 letters, or you can name all 4 of them. So plane EFGH. Okay? Questions on that? All right. Then I'm going to draw you a picture, and you're going to name a few things for me in the picture. So let's say this is my figure. So this is A, B, C, D, E, F, G, and H. Can you tell me segments parallel to AB? Okay, so I want everything that's parallel to this segment, that red segment. What would be parallel to that? GF would be 1. Yep. HE would be 1. And CD would be 1. Okay, can you see that? Those are all the parallel segments, okay? What if I said I want segments skew to CD? Okay, so here's segment CD, right? I want all the segments that are skew to that. HE would be parallel to that, right? HE and CD are parallel. So we want them not to intersect, but not in the same plane. EF would work, yep. EF back here is 1. Okay, you don't get to give any more. Somebody else give me a skew. Here's EF. Skew to CD, right? Not intersecting, although it kind of looks like it because of the way it's drawn, but they're not. What else? Cameron, give me one. Skew to CD. That's the one we already gave. EF. GH would work, right? Never going to touch it. So GH. Hope, can you give me one? Skew to CD. So something that's never going to touch CD, but is not parallel to it. HE would be parallel because it's going the same direction. What? AE would be 1. There's one more. One more that's drawn in anyway. Hope or Justin? Who's got it? You're not Hope or Justin. Do you see it? What's never going to touch CD, but not be parallel to it? That would be BH, this one over here. Okay, so those four are skew. How about, can you tell me some segments that are parallel to plane BCGF? Okay, so BCGF, not BCGF. Oh, I flipped it. BCGH, sorry. So BCGH is this one up here, right? I want segments that are parallel to that plane. Can you give me a segment that's parallel to that? Sure. For a little bit longer. Hope or Justin, can you give me that? So if I said a plane parallel to this, which plane, which flat surface would it be? If this is the top, which one's parallel to it? The bottom, right? So any line on that bottom plane would be parallel. Right, but just segments right now. We're just talking segments. So AE would be parallel. FE would be parallel. FD would be parallel. And AD would be parallel.
The lessons are like ordered like really weird because we did something like this, like where we did the opposite or something, and then now we're just going back into it. But it's like, I know it's different, but it's like kind of what she was saying.
What did we do? What are you talking about?
We did one where we with like we drew like shapes and everything, and then we had to do the opposite or something like that. I forgot.
The opposite?
Yeah, like folds.
Oh, the nets. Yeah, that's.
Together.
Oh, but that's like laying it out flat, right? Now we want to keep it 3-dimensional. Yeah. Okay. Questions on that? Okay, then the next thing we're going to talk about, we have what's called a transversal. And you're going to see a lot of transversals in this chapter. Basically, if I have, actually, no, rewind. We're just going to go like this. If I have this set up, okay, 2 lines, and then there's this line that cuts through the 2 other lines. So this line right here, that is my transversal. It's going to cut through the 2 other lines. With transversals, we're going to create all kinds of different angles, okay? So I'm going to number the angles, and we're going to figure out what we know about them. Okay, let's say we have all these angles. If I, one sec here. Why isn't it let me switch it? Here we go. We're gonna lighten this up a little bit. Okay, with a transversal and the two other lines that you have, you're gonna have two different types of angles. You're gonna have the interior, can you see that? Oh, it takes away everything, doesn't it? Let me write our numbers back in. So angle 3, angle 4, angle 5, and angle 6. We would say those are all on the interior, okay? The way you think of it is the two lines that we're cutting through, if they are between them, right? So everything between those two lines, that's in the interior, okay? Then you also have what are called exterior angles. We're gonna try to lighten that up a little bit. Okay, so the exterior angles would be the ones on the outside. Can you see that up there? What I'm shading right now? Barely, huh? Should have made it a little darker.
What would you call the outside ones?
Exterior. So inside is interior, outside is exterior. So that's going to be, this is exterior, and all of these are exterior. Okay, so if they're inside the lines, they're interior. If they're outside the lines, they're exterior, all right? What happens is there's 4 different types of angles that we create from this. So you will have these 4 types, and I'm going to keep the picture up because we're going to use the picture. You have alternate interior angles. Okay. You have same side interior angles. You have corresponding angles. And then the last one is alternate exterior angles. Okay, so we're going to be talking about these 4 different types of angles a lot in the next 4 lessons, okay? Here's how you tell, okay? It's based on the name that you're given. Cameron, are you with me right now?
Yeah.
I'm not seeing much of your eyeballs. Alternate interior angles, okay? The name tells you where they are. So alternate, when you think of alternate, think alternating. So opposite, alternate, and then interior. Okay, so they're going to be on opposite sides of the transversal and inside the 2 lines. Okay, so alternate interior angles would be, for instance, angle 3. Okay, and if we're thinking alternate, we got to jump to the other side of the transversal, but stay inside the parallel lines. Okay, so 3 and 6 are alternate interiors. Do you see another pair of alternate interiors in this section, in that picture? Yeah, Cameron. 5 and 4, right. So angle 4 and angle 5 would also be alternate interiors. They're on opposite sides of that line, but they're inside the other 2 lines, okay? Okay, so that's alternate interior. Then there's same side interior. What's different? Right, so now it has to be on the same side of the transversal. You awake right now, Justin? That's a really long blink. So same side interiors, you have 3 and 5. Okay, so angle 3 and angle 5 are same side interiors. What's the other pair of same side interiors? 4 and 6. Okay. Then there's corresponding, and corresponding all stems from your vertices. So I have a vertex up here, and I have a vertex down here, okay? We want the ones that are in the corresponding places on that vertex. So the top left on one vertex matches up with the top left on the other vertex, right? Or the bottom right with the bottom right. So from this vertex, okay, from this point up here, if I did my bottom right, that would be 4. What's the bottom right on the other point? 8, right? So from this point, bottom right is 8. So we would say angle 4 and angle 8 are corresponding angles, okay? What would another pair of correspondings be here? If 4 and 8 are corresponding, what's corresponding to 2? 2 and... If it's 4 and 8, then 2 and 6 would be, right? This is top left with top left. So angle 2 and angle 6, okay? Let's see. Justin, what's corresponding to 1? So 4 and 8 are, 2 and 6 are, 1 and not 7. From the vertex, we went top left over here, right? So what's top left from that bottom one? In this set of 4, what's the top left?
5.
That'd be 5, right? So angle 1 and angle 5. And then the last one would be angle 3 and angle 7, okay? So those are corresponding. And then the last type is alternate exterior. So we did alternate interior, right, when they were inside and on opposite sides. Now we want outside but opposite sides. So I could say that angle 1 is an alternate exterior with which angle? What? Did someone say a number? No. 1 and what are alternate exteriors? Which one of these guys? 7 or 8?
8.
It'd be 8, right? Because it has to be on the opposite side of the transversal. So if it's on the left, move it to the right. So 1 and 8, and then 2 and 7. Okay? Questions on those? Okay, I'm going to draw you a picture, and you're going to tell me what types of angles you see. Let's say we have this setup, this transversal. 1, 2, 3, 4, 5, 6, 7, and 8. Where do you see, and I'll just show you the abbreviations I often use, alternate interior angles. I will often write AIA, okay? So where do you see alternate interior angles? Notice our lines are going a different direction now, right? The lines are going this way. The transversal is the one that's more horizontal. Yeah, Cameron. 1 and 4 are vertical angles.
Oh, so it would be
Has to be inside the lines.
2 and 7.
2 and 7, right? Angle 2 and angle 7. Okay. What's another pair of alternate interiors? Cameron can't give it to me. 4 and 5. Okay, so those are alternate interiors. How about alternate exterior angles? Okay, so now we want to be outside. That means we're using outside angles. So those are your outside angles. Which ones are alternates? Which ones are on opposite sides of the transversal? Let's say we start with 1. Angle 1 and which angle over here? Should be on the outside, but opposite sides. That'd be angle 8. Right. Okay, or angle 3 with angle 6, right? How about corresponding? What would be corresponding to what's corresponding to angle 1? So think, here's my vertex, here's my other vertex. Which ones sit in the same place? So angle 1 and angle 5, right? Top left with, top left. So angle 1 and angle 5. What are some other correspondings? 2 and 6, right? 2 and 6, top right with top right. What else? That was the first one we did. 3 and 7, and 4 and 8. Okay, that's corresponding. And then the last one is same side interior angles. So SSIA is how I sometimes shorten that. So on the same side of the transversal, which one's my transversal right now? The vertical or the horizontal? Horizontal, right? So here's my transversal. I want angles that are on the same side of that, so both on top or both on bottom, and inside the lines. 2 and what? 2 and 5, or 4 and 7. Okay, questions on those? That's the lesson. And we'll do a lot more with that in the next couple days.